Hi. Today we are going to discuss about CMOS transistors. What is CMOS? CMOS stands for Complementary Metal Oxide Semiconductor. Complementary Metal Oxide Semiconductor. So the CMOS structure, it's a combination of NMOS as well as PMOS transistors. So we know that NMOS transistor, it is good for transmission of logic 0 and PMOS transistor is good for transmission of logic 1. Here we are combining this NMOS as well as PMOS, so the CMOS transistor will have the advantage of transmission of better logic 0 as well as logic 1. So now we will see the architecture of CMOS transistor. So the CMOS transistor, it will have a PMOS transistor and NMOS transistor, and always this PMOS transistor will be on the pull-up on the top and NMOS transistor will be on the bottom. And the CMOS transistor, the PMOS and NMOS, the gate of these two transistors are connected and it will be connected with input voltage. And always the source of the PMOS transistor, it will be connected to the VDD, and source of the NMOS transistor, it will be connected to the ground, and the drain of these two transistors are connected and the output will be taken here. So this is the symbol of CMOS transistor. So Vin is our input and V out. So the output will be always complement of our input. So now we will see how this output will be complement of this input. So we know that PMOS transistor will turn to on when applying logic 0 on the input, and it will be turned to off when we apply logic 1. And similarly that NMOS transistor will be turned to on when we apply logic 1 on the input, and it will be turned off during logic 0 is applied on the input. So now we are going to see how this CMOS transistor will work as an inverter. So we assume it as, now we are applying an input voltage like this. So input voltage, initially it is 0, then it is changing from 0 to 5 volt. That means logic 0 to logic 1. So now if this input voltage is applied here, 0 to 5 volt, then what will happen you will see. Suppose our input voltage is 0, then what will happen, here it is 0, here also 0. So our PMOS transistor will be turned to on and NMOS transistor is turned to off. So when PMOS is turned to on, that means the source and drain of this transistor will be connected. So your VDD supply, it's directly connected to our output. So we will get the output voltage of VDD or equal to 5 volt. If we connect VDD is 5 volt, we will get the output is 5 volt. So when we apply 0 volt on this input, we are getting the 5 volt in the output. So output is always complement of the input. Then similarly we will see what will happen when input is changes from 0 to 5 volt. So that transfer curve from 0 to input is changing from 0 to 5, it is called transfer characteristics. Transfer characteristics. So what is the transfer characteristics is? It is a graph drawn between input voltage versus output voltage. So in x-axis it is input voltage, and our y-axis it is in output voltage. So it will be drawn between input versus output voltage. So when our input voltage is 0, our output voltage is VDD. So we will get maximum voltage. So when we apply the input voltage is 0 to 5, so we will see what will happen. So now we can divide this input voltage like this. Input is changing from 0 to 5 volt or VDD. So now what will happen you will see. So maybe this may be 1 volt, this is 2 volt and 3 and 4 and 5. So when our input voltage is 0, we will get 5 volt. When our input voltage is up to 1 volt, up to 1 volt, then it will be, this PMOS is fully in saturation and NMOS is in cutoff. So what will happen, till the input voltage of 1 volt, you will get the maximum output voltage. Suppose when our input voltage reaches to the 2 volt, so now the input voltage Vin to the NMOS transistor is above the threshold voltage. So now a channel has been formed between the drain and source. A small layer of channel is formed. Then it starts conduct. By the time this PMOS transistor, when we apply 2 volt on the gate of this PMOS, then the channel slowly does reduce. Initially it is in a saturation. Now the conduction of the PMOS transistor is slowly reduced. So what will happen? This is also partially on and this is also in on. So your input voltage is, your VDD is connected to Vout as well as Vout is connected to the ground through the NMOS transistor. So your output voltage starts slowly decrease. So this may be a 2 volt. At the 2 volt, when you apply 2 volt, the output voltage starts degrade from 5 volt to some 4 volt. Then when we increase this input voltage to 3, then again the conduction of the NMOS transistor will increase. By that same time, the conduction of the PMOS transistor will be reduced. So again your output voltage at the 3, your conduction voltage will be, again it will be reduced. Your output voltage will be reduced. Then again, if your input voltage is almost reaches to 4, your NMOS transistor is greater than, the VGS value is greater than your VGS minus VT. So your NMOS transistor is enter into the saturation. And our PMOS transistor is enter into the cutoff when we apply 4. Because this 4 volt is almost nearing to the logic 1. So our PMOS transistor will turn to off. So by the time our output voltage will be almost coming to 0 point. When we apply 5 volt, our NMOS is completely on and our PMOS is completely off. So this totally it will act as an open circuit and this completely it is on. So our entire output voltage will go to the ground. So your output voltage Vout equal to 0. So when we apply 5 volt on the input side, your output voltage is reduced to 0. So this characteristic curve, relationship between Vin versus Vout is called as transfer curve. Now we will see what is the advantage of this CMOS technology. Why should we go for CMOS? So CMOS technology, the major advantage is the power dissipation of this CMOS transistor is very less. How we can see now? So before that, so during this transfer curve, this transfer characteristics is now it is classified into these 5 different regions. So in this region 1, your PMOS is fully in on and NMOS is in off. Whereas this region 2, here P is in fully on but N is partially it is also on. And this region, region number 3, almost P is also on, N is on, because it is a middle 2 to 3 volt, both transistors are on in the same conduction. When it reaches to 4, N is in almost saturation and P is also on but it is going to be off. And the region number 5, your P is completely off and our NMOS is completely on. Okay. So now we will see what is the major advantage. The advantage of this CMOS is power dissipation is less. We will see that how this power dissipation is less in the CMOS transistor. Normally the power dissipation P equal to I square into R, where this I is represents the current flow from VDD to ground. So when the current will flow from VDD to ground here, so when both transistors are on, then only the current will flow from VDD to ground. So otherwise there won't be any direct contact between VDD to ground. Either P is on, only the P is on, then the VDD is directly connected to Vout. If N is on, Vout is directly connected to the ground, and there won't be any direct connections between VDD to ground. So only during the transition of logic 0 to logic 1 or logic 1 to logic 0, both transistors are in on. So when we look into this transfer curve, where both transistors are on from the region number 2 to region number 4, only this period both NMOS and PMOS is on, and rest of the period your either NMOS is on or PMOS is only on. Right. And normally the transition period will be less, mostly that logic 1 period or logic period will be the highest period, and the transition period is very small. Always it will be like this only. So only the transistor, the region number 2 to 4, the conduction is between VDD to ground through the PMOS as well as NMOS transistor. So in this, at the region number 2, your P is in saturation and N is in initial conduction. So a small amount of current, it starts flow from VDD to ground. So now the current starts. And during this region only, both transistors are in maximum saturation, nearing saturation. So during that time, the maximum current will go to the VDD to ground. Then again the region number 4, it will be N, and region number 5, there won't be any current. So only the current will flow from VDD to ground during the region of 2 to 4. So the short circuit current is very minimum because it will flow only for a very short period. Then this I will be always negligible amount. So this I square into R, the resistance of this path between VDD to ground, that will be R. While multiplying this I square into R, you will get power dissipation. So this power dissipation will be always very minimum. How it will be minimum is, suppose when we look into the NMOS alone, then PMOS is not there, and here also NMOS. So when we apply logic 1 on this input side, then both transistors will be in on condition. So entire duration of this logic 1, the current will flow from VDD to ground. So that I square will be more. So I square into R is it's always again high. So NMOS transistor, during the input is logic 1, enormous current will flow from VDD to ground. So that will make more power dissipation. Similarly, if it is PMOS, during the logic 0, both transistors are in on. So during logic 0, enormous current will flow from VDD to ground. That time also the current will be more. But in the CMOS, during logic 0 or logic 1, both transistors will not be on, and only during the transitions both will be on, so that the short circuit current will be very less in the CMOS transistor, so that the power dissipation of the CMOS transistor is very minimum. So that's all about the CMOS transistors.